All right, we'll give it just another minute and then we'll go ahead and get started, y'all. All right, well, welcome everybody. We're so excited to have you today. I guess I'll start with an introduction. So hello, my name is Cassidy Dunaway, and I'm an AmeriCorps member at MountainTrue. And part of my job is to host these MountainTrue University series. So if this is your first MountainTrue University, it's a speaker series where various members of our staff and friends of the organization give talks about areas that they work on or have expertise in. If you are interested in finding some of our past recordings of MountainTrue University, you can find them on our website. Today, we're going to hear from MountainTrue's very own Ecologist and Public Lands Director, Bob Gale, and MountainTrue's Field Biologist, Josh Kelly. Together, they will provide an overview of the likely effects of global climate change on the people and ecosystems of the Blue Ridge Mountains. And they will also discuss the adaptation and mitigation strategies that are needed to maintain the resilience of our mountain home. If you are not familiar with MountainTrue, we are an environmental conservation organization that works regionally, mostly in Western North Carolina, to protect our resilient forests, our clean waters, and our healthy communities. Check out our website to find out more about what we do. A little bit of housekeeping. Since this is a webinar, we cannot see or hear you, but you can see and hear us. If you have any questions during the discussion, you can type them into the Q&A below, and we will get to them at the end of the discussion. So I will go ahead and I will hand it over to Bob to get us started.
Okay, thanks, Cassidy. Yes, Bob Gale, Ecologist and Public Lands Director at MountainTrue. This is my 23rd year here. Great organization, obviously, in my opinion. I'm going to just sort of interject a few times as needed, but I'm turning, this whole presentation is basically going to be given by our wonderful field biologist, Josh Kelly. So I'll turn it on over to him now.
You're on mute, Josh, sorry.
Oh, thank you so much. I was, yeah, I had it on mute there. So thanks, Bob, and thanks, Cassidy. So yeah, Bob and I are going to do our very best as biologists and ecologists to explain some climate science and bring that down to the local level for you all, and also to hopefully make it entertaining. My guess is that a lot of you probably are fairly familiar with concepts around climate change, but we are going to cover some basics as well as some very particular local phenomena. So Cassidy gave a great introduction. I don't think I even need to give the title slide, but we'll talk a little bit about MountainTrue and how we work for clean water, healthy communities, and resilient forest throughout our region. Bob and I, of course, are in our public lands program, and we are the main forest stewards on MountainTrue staff, along with our forest keeper coordinator, Timia Dame. MountainTrue focuses on a whole host of issues across our region, from land use to restoring and protecting our public forests and improving water quality, promoting clean energy, and encouraging civic engagement by environmentally minded citizens. And we are focused in our work on 23 counties in Western North Carolina and adjacent areas in Georgia and Tennessee, all of which are in the Blue Ridge Mountains. And so on this map, you can see the Blue Ridge Mountains highlighted, and I always like to focus my talks on the place. And so the Blue Ridge is this ecoregion between the Piedmont to the east and the Ridge and Valley to the west. These are very old mountains, the highest mountains in Eastern North America, and very, very diverse in their topography, their rainfall, geology, and a lot of other aspects. As a biologist, I also like to focus people on the fantastic biological diversity in our mountains. And I think we have a lot to learn from the biological diversity here when it comes to climate change. This area is, as far as the temperate world goes, about as diverse as you can get. The tropics are, are much more diverse than the temperate world in general, but as far as areas that have a winter, the Southern Blue Ridge is right up there at the top globally. And we are a global center of diversity for all sorts of animals that rely on abundant water, like salamanders, crayfish, land snails, and freshwater mussels. Our region has incredibly high diversity of plants, fish, and arthropods generally. And, we have ecosystem diversity representing about 10 degrees of latitude. From hiking from the bottom of the Blue Ridge Mountains in Old Fort and climbing up to the top of Mount Mitchell, you could conceivably do that in a day if you're in really good shape. And in that same foot journey, that's about the same as a 700-mile journey to the north. And so within that range of elevations, we essentially have a lot of different climates, which has a lot to do with the diversity that we have. So yeah, our diversity results from that large range of elevations and a diversity of local climate and weather. It results from geographic and geologic diversity that leads to lots of different biophysical settings and ecosystems that have diverse disturbance regimes. So I'm talking there about those disturbance regimes. We have areas in the mountains that are the driest places in North Carolina. Dry Ridge in northern Buncombe County, for instance, this is a huge rain shadow and it's estimated to get around 30 inches of rain a year. And there are points just 20 miles to the southwest that get over 120 inches of rain a year, so 4 times more rain. But those differences in rainfall correlate to differences in fire probability. And whether or not you're on the top of the mountain or the bottom of the mountain has a lot to do with how much wind and snow disturbance you get. As far as deep history, one of the big keys to the diversity here is these mountains have never had glaciers on top of them. Maybe some small ice fields at the top of the mountains in the last ice age, but we've never had big glaciers. And we're also close to the Gulf of Mexico, which provides most of the moisture that we get here. There's a lot of other factors as well. And I didn't follow up on Bob's suggestion with this slide, which was just to use one picture of this ice sheet. But this is just to really drive home this point about the Southern Appalachians, which, were never underneath the ice sheets during the Pleistocene. And everything underneath those ice sheets was essentially scraped free of complex life. And all the life up north was actually recolonized from places like the Southern Appalachians. Along with being a great place for a multitude of different living things, this is a great place for people to live too. And it's because of that fantastic temperate environment we have here. It has given rise to a lot of cultural diversity and a lot of fantastic cultural traditions, musical, medicinal, oral histories, stretching back thousands of years into the past and continuing on today. So how will climate change affect us, and how can we ensure that as climate change does affect this region, it remains a great place for both people and the natural world? So we should probably go over the basics here, which is that we live on a ball in space. And without our atmosphere, we wouldn't be here. Our atmosphere is the key to making this planet hospitable. If we didn't have an atmosphere, it would be about -18 Fahrenheit on the surface of the Earth on average all the time. Because of our atmosphere, the surface temperature on the Earth averages 57 Fahrenheit. And our atmosphere keeps us warm because of the greenhouse gases it contains. We're talking carbon dioxide, methane, nitrous oxide, and water vapor primarily. Of those, carbon dioxide is the strongest and most powerful driver of our greenhouse. And that is because carbon dioxide is the longest lived of all these greenhouse gases. We know through sources like ice cores, tree cores, et cetera, that as the carbon dioxide in the atmosphere fluctuates, so does the Earth's temperature. And as the temperature fluctuates, so do some of these other greenhouse gases like methane. So for example, as the climate warms, there's more decomposition, both in the soil and on the surface of the land and in the sediments in the ocean. And that temperature and decomposition drives the release of methane, which is also a powerful greenhouse gas. However, it's very short-lived. Only stays in the atmosphere 10 to 20 years. Water vapor similarly, as the climate warms, there's more evaporation, more water vapor in the atmosphere. And so it's another feedback loop to warming the planet as carbon dioxide increases. So where were we and where are we now? Well, prior to industrialization, CO2 was about 280 parts per million in the atmosphere, and today we are up around 415 parts per million. And so, yeah, we've had a big change. CO2 varies throughout the year based on what plants do. Plants take up CO2 and can vary the CO2 by about 2 to 4 parts per million during the growing season, particularly as the northern hemisphere with most of the land mass comes into its growing season. There are lots of other sources of CO2 besides human activity, but the primary source has been the burning of fossil fuels, coal, oil, and natural gas, and also the deforestation of our forests. So as we remove forest, that releases carbon into the atmosphere from both the trees decomposing, trees being burned, and also from the soil and increased heating of the soil.
And so I'd like to emphasize back on that slide, a lot of people still ask me, they hear that, they say, well, the climate has always changed. There's always been a change in temperature and greenhouse gases. That's natural. What's the problem? I'm amazed that many people have not seen this particular slide as much as it's been put out there. Those of us that are really geeky know about this, but this is called the hockey stick. And it's very clear that from the time of the Industrial Revolution that we have caused things to just skyrocket beyond natural cycles, as you can see by this slide. I just wanted to make sure people understand that.
Thanks, Bob. And so, yeah, that increase in carbon dioxide in the atmosphere is driving the increase in temperatures that are being observed. And we can measure that increase in temperature in a lot of different ways. Temperature over the land. We can measure it via satellites and weather balloons and temperature in the atmosphere, high above the land. We can measure the increased humidity that we're observing all over the planet. Increased ocean temperatures and sea surface temperatures. Decreasing sea ice is a easily observable phenomenon. You've probably seen photos of the Arctic and how the sea ice in the Arctic is declining year over year. And decreasing glaciers, decreasing snow cover, increasing sea level. These are all measurements that we can make that affirm that our planet is warming, and that it's due to almost beyond a shadow of a doubt due to carbon dioxide in the atmosphere. So we could talk about all these things in depth, like Arctic amplification, as in how the high latitudes are warming faster than the lower latitudes, glaciers, permafrost, all these different things. There's all sorts of downstream effects like ocean acidification. As the carbon in the atmosphere increases, carbonic acid in the ocean increases, which disrupts the ecology of our oceans, especially in coral reefs and for shell forming organisms. But mostly we're going to talk about three big trends in this talk here. We're going to talk about the increase of record heat and the decrease of record cold. So as this warming is occurring, we've been able to observe over time in these 30-year periods change. So baseline that we have is basically the average climate over the past 120 years or so, where we've had very good measurements of weather and climate across the planet. And in that first graph, you can see what the climate was like from 1951 to 1980. If you shift it to the right, 10 years, 1981 to 1991, you can see those warm temperatures starting to move, moving to the right. And again, 91 to 2000, moving further to the right, and 2001 to 2011, you can see even further to the right. So you can see how the hottest temperatures on the right-hand side are outside of anything observed from 1951 to 1980. And likewise, the coldest temperatures observed in 1951 to 1980 aren't really happening anymore, at least not at the same frequency. So everything is shifting. The lows are shifting to being warmer, and the highs are also getting warmer. And we know that according to NOAA and NASA, the last 7 years rank as the 7 hottest years on record. That's a heck of a streak to have going. And, a sobering thought is that, 2021 is going to be another one of the hottest years on record, but it's also going to be one of the coldest years of the rest of our life. These changes are in motion, and we can't stop this change that's in motion, at least not for another, if we stopped all of our greenhouse emissions today, we'd probably observe warming for another 50 years, is what scientists are telling us. So we're going to have to live with some degree of warming, some degree of climate change. And what that looks like, and what we've already observed, is a much longer growing season in some cases, and a lot more heat. So for instance, the last 90-degree day of the year is now occurring 15 days later in the calendar at Raleigh-Durham, about the same in Atlanta, about 15 days later in Atlanta. So these places are getting, if you don't like heat, they're becoming less and less habitable. And I think we're going to see that all over the hot parts of this country and this world. Interestingly, Asheville, at about the same latitude as Raleigh-Durham, has essentially seen no change in the heat we're seeing here as far as how late that last 85-degree day occurs in Asheville. So that has some implications. So let's think about the effects of a warming climate and hotter weather on natural systems. So I think it's pretty clear that plants and animals dependent on cool temperatures will decline, both worldwide and locally. Drought stress will increase because hotter temperatures drive more evapotranspiration. That's when plants draw water out of the ground. And that will lead to more drought stress on our natural systems and on our agriculture as well. And plants and animals associated with high elevations will be especially hard hit locally, and so will cool water species like trout. So on the tops of our mountains here, we have this amazing ecosystem of spruce fir forest, which is unique from the spruce fir forest anywhere else in the world. And it's unique because it's been there for so long. And it's also unique because it's isolated from these other spruce fir forests. There's islands on top of the mountain where species like Carolina northern flying squirrel, Weller's salamander, and the spruce fir moss spider have been islanded for a very long time and are totally distinct lineages. And it's quite possible that in the next 100 to 200 years that this ecosystem will no longer exist. And who knows what will happen to all the different creatures dependent on this ecosystem. It's also somewhat possible, though not very likely, that there will be enough buffering effects from the elevation in our mountains to allow some portion of this ecosystem to persist. It's an open question, but most likely, I think, we're going to see some very major impacts to these high elevation ecosystems like spruce fir forest. As far as people are concerned, warming climate and hotter weather is going to mean a lot of changes for our region. And that's because our region, the Southern Appalachians, will remain a lot more habitable than surrounding regions. So if you live in Atlanta or Birmingham or Miami, Florida, or any number of places in the South, those places are going to become increasingly difficult to live. And places like the Southern Appalachians are going to remain, a lot more temperate. And so I think we're likely to see a lot of migration here. And this is going to place a lot of stress on our natural systems and our infrastructure. And so I think planning for how we're going to handle that increase in population that we're certain to see from climate refugees is really important. This is when we're going to get into talking about mitigation and adaptation options for this area. And I think what I want to emphasize here is that mitigation is everything we can do to prevent carbon dioxide and other greenhouse gases from entering the atmosphere. And adaptation is what we are doing to adapt to the reality that we are going to have to deal with some level of global warming and some level of climate change. So there's some of this we can't escape and we need to adapt to that. We can mitigate how bad it's going to get by keeping greenhouse gases out of the atmosphere. So mitigation strategies for global warming. Like I said, we got to keep the CO2 out of the atmosphere. That looks like energy efficiency, decreasing our consumption of energy and using carbon-free energy sources. We can increase carbon sequestration in natural vegetation. Main way we can do that around here is by managing for older, more resilient forests. So the older we allow our forests to get and the bigger we allow the trees to get, the more carbon we're going to store in the forests. We also need to make sure that carbon's resilient. So we need to make sure that our forests are not at big danger from diseases, pests, and wildfires. And, perhaps counterintuitively, one of the ways we can do that is by actually burning our forests and preventing the kind of fuel buildups that under a really bad wildfire could lead to our forest completely burning down. We can also increase carbon sequestration in agricultural lands by using fewer chemical inputs and perhaps by tilling the soil less, and also increase efficiency of water use. So as far as adaptation strategies for global warming, more shade from trees is a great way to keep our habitable spaces cooler. Less blacktop is a great way to keep our cities from heating up. Having buildings with reflective surfaces is another great way to keep our habitable areas from getting hotter. And having more access to water for people to swim is another strategy for helping people cool down in the hot summer months. Without necessarily using quite as much air conditioning, which depending on your energy source can be another driver of greenhouse gases. And better connectivity of natural areas, because as the planet warms, these species that can't deal with the warm weather are going to need to either move up the mountain or move north. And so we need them to have corridors and connectivity to be able to do so. And moving on to the second trend, and just a reminder, if you have any questions or comments, you can use that Q&A button at the bottom of the screen and chime in. Big rain is increasing. And what I mean by that is that rainfall intensity is increasing as well as overall precipitation. So these are the trends across North America. This is the observed change in heavy precipitation. In the Southeast, you can see we've had a 27% increase in heavy precipitation observed already. And so, large rain events are now more than norm. That rainfall rate per hour is going up. And this has a lot of consequences. And it's driven by several things. One, probably primary driver is the warming of the oceans. And this leads to more evaporation off the oceans. And also, warmer air can hold more of that moisture that's evaporated than colder air. So there's actually more moisture in air as a law of physics that's warm than air that's cool. And this allows for heavier rainfall events. Warming oceans also lead to stronger hurricanes. It seems like as far as hurricane frequency, there's been no observed increase in that due to global warming, but hurricane intensity is definitely getting stronger. And we're seeing that over and over again with huge storms like Hurricane Haiyan, or Cyclone Haiyan, which is the strongest tropical cyclone ever observed, probably should have been a Category 6 that hit the Philippines several years ago, and then like Hurricane Dorian that ravaged the Bahamas 2 years ago was the strongest Atlantic hurricane ever observed. And more strong hurricanes. So what are the effects of more intense rain? Floods will become larger and more frequent. Landslides will become more frequent, and streams will suffer from increased scour and sediment. And infrastructure that interacts with streams or water in any way will be stressed. We're seeing lots of sinkholes emerge across Asheville from underground water flowing underneath roads and parking lots. Definitely seeing a lot of all of these other impacts. Looks like we've had a question come in. And I'll get to that towards the end, David, about David Miller asked, are there any measurable effects related to climate change and loss of biodiversity in Western North Carolina? Bob and I will address that at the end. Great question. So yeah, let's look at some of these local examples a little bit here. So here's some pictures of floods in Asheville. On the top left, you have flooding in Biltmore Village in 2004. Those bottom three photos are from 2016, which is the largest flood observed in the Asheville area. But we have a lot of exposure to flooding in Western North Carolina because we don't have a lot of flat land. People tend to build on flat land and farm on flat land. And we do get a lot of rainfall, and it tends to run off quickly because we have pretty steep mountains. Landslides are a really big danger that I don't think are appreciated quite enough. And so these are all photos of landslides that have happened in the past 15 years. We've got the Peak Creek landslide that killed 5 people in Macon County in 2004 in these slides here. And this is a map of the known landslide locations in Western North Carolina. I think an important thing to know here is that just because an area doesn't have a dot on the map here doesn't mean there haven't been landslides. It means that those counties haven't yet been mapped. And something that MountainTrue is really asking our members to lobby for is increased mapping of landslides. There was a great program in the early 2000s to map these. And unfortunately, when the budget got tight in 2010, the legislature killed that effort. And there's a big need for citizens to speak up and let the legislature know that we want to know where landslide hazard areas are so that we can prevent dangerous developments in those areas. And development is one of the leading causes of landslides, actually, by destabilizing steep slopes.
Let me add to a clarification, just so people realize, climatologists have shown us we have always had floods and droughts here in the mountains. But what's happening now is that they're becoming more severe, they're happening more often, and sometimes happening in a more extensive, over more time. Back to you, Josh.
Definitely. So let's think about some adaptation strategies for increased rainfall intensity. Big adaptation strategy is to avoid building on floodplains, steep slopes, and landslide hazard zones. This is just going to cause a lot of misery for the people who end up building there and a lot of expense for the rest of us who are paying insurance or paying taxes and or just contributing to society in general and are going to have to bail those folks out who end up living in those kinds of places. We really need to improve our bridges, roads, and other infrastructure. In some cases, we're going to need to make our bridges bigger. Pretty much everywhere, they need to be upgraded and made stronger. We need more vegetation on our stream banks to keep our streams from shifting too much and increasing erosion. We need to reduce impervious surface, like parking lots, because that drives very quick runoff and drives flash flooding. Moving on to trend number 3, drought will become severe. So those first two trends, the increase in warming and the increase in rainfall, are very strong signals in climate data. The drought signal isn't quite as strong, but it's there. And I think a great case study for us in this region is the drought of 2016. And so this is a map of the last 180 days of drought of precipitation as of December 1st, 2016. And you can see across the entire South, and particularly the southwestern North Carolina, incredibly low precipitation relative to normal. So the impacts of that kind of drought are stress to aquatic wildlife, talking fish and other wildlife in streams. As streams get smaller, there's less habitat there and they warm up quite a bit too. Decreased water availability for wildlife and humans, and more dangerous conditions for wildfires being probably of major interest to people. And global warming has a lot of feedback with wildfire. So this is a chart showing the response to fire and fuel to possible changes in various atmospheric processes. And you can go down this chart and look at different changes like increased temperature. And then to the right, it shows the confidence in that prediction is very high. Fire response, an increase in fire frequency, an increase in intensity, an increase in the seasons in which fires can occur, increase in the area that can burn, et cetera. And you go down the list. Decreased precipitation, that's probably not going to happen. We're probably going to see increased precipitation because we have low confidence there. Increased drought, we have a high confidence that droughts will become more severe and possibly more frequent. So again, that correlates with increased frequency of fire, increased intensity, increased seasonality, and increased area of fire. So those are the kind of the main feedback loops. There are increased temperature and increased drought. The other factors, we don't really know how it's going to increased planetary warming is going to increase winds or not. It's kind of likely that it will, because as you have more heat in the atmosphere, you have more energy there. And more energy will probably lead to stronger wind events, but the confidence in that is low. Same thing with lightning. We don't have a high confidence in what the trend with lightning will be, but lightning is a driver of wildfire in many cases. This slide shows change in May fire potential from 2010 to 2060. And basically what you need to know is on the left is where we are now approximately, and we're moving towards that situation on the right, whereas those colors get darker, we're seeing more and more potential for fires in May. In our region, we're a deciduous forest region, So most of our fires occur when the leaves are off the trees, and it allows sunlight to get to the ground, the leaves, and the other fuels to dry out. So, spring and April and May are one time to look at. The other time to look at, and where we're seeing the biggest change, is in the fall. So this is predicted change in drought index from 2010 to 2060. And the solid line is 2010, the dotted line is 2060. And what you're seeing there is a huge increase in fire potential from late summer into fall. And we are seeing this confirmed so far in early returns from wildfire seasons. And again, the fires of 2016 are a great case study, with fall 2016 being the most active fire season since at least 1942. Over 72,000 acres burned in Western North Carolina alone, and approximately 120,000 acres burned throughout the Southern Blue Ridge. And the Gatlinburg fires in Tennessee were the most expensive and deadly in the region in a century. Interestingly, most of those fires were human caused. There were two large fires, the Rough Ridge Fire and Boteler Fire, that were lightning strike fires. And you can see the cause of that fire, again, is that hot and dry weather we had. And 2016 was the hottest and driest fall on record locally. This is a map of weather stations throughout the region. And on the left, you can see temperature, observed mean temperature from September 1st to November 28th. Look at all the number ones on that map. And then you can see observed total precipitation on the right. Those number ones and twos are how dry they are. Those are the first and second driest years on record across the region that you're seeing there. So that heat combined with dryness is a pretty serious combination when it comes to fire. And I think, when you're thinking about fire, it's important to understand the drivers of fire, which are weather, topography, fuel, and the ignition source. So some of those things we can't control. Weather and topography are a given. Steep lands are going to burn more dangerously than less steep lands, because fire likes to burn uphill. We can't control the weather, not at least on a specific level. We can drive the weather with our actions through putting greenhouse gases in the atmosphere or not, but we cannot control it on the local level whatsoever. And so, high winds are something that are very dangerous during fire, as is low relative humidity and high temperatures. What we can control to some extent are the fuels. So on the left, you see an area that has had controlled burns, and the fuels have decreased, and it's changed from a shrubby fuel model to a grassy fuel model. And on the bottom right, you can see an area just a mile away that hasn't had any fire, and it's very shrubby, and it's a pine forest type that is extremely flammable, and if those shrubs catch fire, it's going to create very dangerous conditions. They're going to be very dangerous for firefighters to try to control. Interestingly enough, and maybe counterintuitively, the area on the left is actually likely to burn more frequently, because grass can catch fire easier than those shrubs. But when it does catch fire, it'll be much less dangerous than the area to the right. So that principle that fire frequency is inversely proportional to fire severity. So more frequent fire actually leads to cooler fires than less frequent fire. The last thing we can control to some extent is the ignition source. So we can control, for instance, on the left, all those fires occurred in cool months, generally February, March, April. Fires that burn in those times are much easier to control, and they're mostly lit by people. Fires that occur from April on are oftentimes lightning fires, and when they burn during droughts, and they're really dangerous. Another thing to consider is that fire and heavy rainfall sometimes interact. And so this is a picture of Highway 1974 in the Nantahala Gorge. This area had a pretty severe wildfire in 2016 on very steep slopes above the Nantahala Gorge. And in the years following that, 2018, 19, and 20 were three of the wettest years on record in Western North Carolina. And we've seen the combination of those slopes that were denuded by wildfire and having less roots to hold the soil in place, and those heavy rainfall years, we've seen repeated landslides close that highway. And so this is an example of our infrastructure perhaps having some real challenges with climate change. And so it's not just where we live, but how we get around in our transportation. Yeah, there's a lot of good adaptation strategies for living with fire. One of them I've mentioned already is controlled fire or prescribed fire. Same thing, just called by different names. Mechanical fuel reduction is another strategy. So if you have a house that's surrounded by dense vegetation, actually removing that vegetation and converting it to grass or some other herbaceous vegetation, green vegetation, is going to make your house safer. Community planning and building codes that prevent people from building in dangerous places and ensure that people, if there is a wildfire, have an escape route. One of the big tragedies in Gatlinburg is that there was no requirement that people have, that neighborhoods put in multiple escape routes. So some people only had one road to get out of their neighborhood on, and trees fell across those roads and they weren't able to get out. And then finally, creating defensible spaces. Avoiding living in steep areas with fire-prone vegetation is a first step, but if you live in one of those places or anywhere really, you need a defensible space around your house. That looks like an area where it's easier to fight fire. And there's a great program called FireWise that if you live in a community that you think might be a danger to wildfire, you can sign up for. Well, I've talked about a lot of the changes that are coming, and a lot of them are pretty serious and pretty intimidating. So what cause do we have to hope when it comes to climate change in our region? Well, I think one cause we have to hope is we can look to the natural world for inspiration. We live in this fantastic area of great biological diversity that has weathered so many changes through time. And real nearby in East Tennessee, there's this fantastic fossil site, the Gray fossil site. These are sinkholes that are filled with sediments, including pollen and charcoal. These are dated between 4.5 and 7 million years ago by fossils where these sinkholes filled in. And you wouldn't know these sinkholes are there unless you were digging. And there's actually a highway project through the area that did just that. They dug into these areas and started uncovering fossils, and they actually rerouted the highway to preserve this fantastic site. What we know about this time on Earth is that carbon dioxide levels were higher than they are now. They were over 500 parts per million. And the Earth was warmer than it is now. And at that time, alligators were swimming in the Tennessee River, and red panda bears were in the trees, and there was a mixture of tropical and temperate flora and fauna. At the same time, we see some of the species that, or at least the ancestors of the species that we have in the region now, still in the region. And we know that from the pollen that's in these sinkholes. So this area has tremendous resiliency to both warming and cooling. But we need to make sure that it retains that resiliency. And the biggest way we can do that is through our actions as far as our development and how we live with the land. And we really need to work together. So here's an example of something MountainTrue has done. We've stabilized miles and miles and miles of stream banks in the French Broad River Basin and the Hiwassee River Basin and the Watauga River Basin. One of the ways we do that is by revegetating these eroding banks. These are willow stakes that are cut off live willow trees and then pounded into the bank, and they actually root and grow into the bank. And this will make them more resilient to flooding and erosion. This is just one small example of people working together to make our area more resilient. And we need a lot more of this. We need this in every arena, from clean energy deployment to affordable housing and energy efficient housing, to transportation options that are energy efficient and are resilient to the big floods that we're going to see in this region. But I really do believe that if we work together and if we take care of this land, that it will take care of us. And it has been a hospitable place to live for all sorts of life forms back into deep time. And if we don't mess it up, if we do our best to take care of this place, we have a really good chance of having it be a resilient place going forward. But we do need to make room for the more people that are coming without destroying our natural infrastructure that gives us our resilience. And that's pretty much all I have to say about this. And I guess we can get into discussion and questions at this point.
I'd just add to the resiliency of our mountains that we've seen that through time, remarkably resilient through climate changes. But we also are lucky to have so much public land protected in the Southern Alps and in North Carolina. And we have a lot of old growth forests and forests that are reaching once again an old growth condition. Keeping those intact is really important for carbon sequestration, which Josh alluded to earlier.
Yeah, that's a great point, Bob. And one statistic I like to tell people is that in 1950, the Blue Ridge Mountains were 50% forested. Today, they are 80% forested. That represents a huge accumulation of carbon and a great forest restoration story. And as much as we can allow those forests to remain intact and to continue sequestering carbon, the better it will be for everyone all over the planet. Looks like we got some questions coming in. Let's talk about David's question, Bob. Any measurable effects related to climate change and loss of biodiversity in Western North Carolina? So David, what I can say is that I'm not aware of any studies that relate any extirpations or extinctions that have occurred so far to climate change, but I think we have some indications that climate change is going to make life tough for a lot of different species in our area. And one example is non-native invasive plants, and Bob knows a lot about that.
Yeah, we've certainly, we know that there are some non-native invasives that actually respond quicker to a warmer climate than some of our native species. And that's caused them to expand quicker in areas that they have invaded. So that's one thing. There are a couple other studies that's very preliminary, but globally, that have found that studying woody vines called lianas in forests in a couple places in the world appear to be growing faster than the forests that they evolved in. So there's some concern about will that cause a change in the ecology of some forests in the world? We don't know yet, but these are things we're just seeing and learning about. So there are some changes we're seeing, and it'll be interesting to see what studies show in the future on these. We got another question?
Nice. Yeah, we got a couple others. Ashley Chase asked, how can we get involved in volunteering on things like river stabilization? Ashley, I would say go to MountainTrue.org and sign up for our events and look at our events calendar. If you get on our email list, you'll learn about all these different things, and you can choose, if you're particularly interested in water, to sign up for the water events or water notifications, or if you're particularly interested in forest and water, sign up for both, or maybe you're interested in clean energy, et cetera. We have lots of different ways that folks can get involved. Really appreciate your interest. And then David Miller asks again, what are go-to web resources for climate change info in Western North Carolina? I'm probably not as knowledgeable about that as I could be, but the Collider is a great organization in Nashville that works on climate resilience. I think the NOAA website is always good for looking as far as data and what the trends are with weather. That's the National Oceanic and Atmospheric Administration. Bob, do you have any, or Cassidy, do you have any other things you'd like to point to folks?
I think NOAA, like you said, and if you do some research on hurricanes, you can see the direct correlations between the warming oceans causing higher energy, which is generating more powerful hurricanes. So I think you've given it. The Collider is a good spot to go with, and NOAA. I can't think of any others.
I don't have any particular suggestions on that particular question. Oh, looks like we just got another question. It says, are there any WNC universities doing CC research, climate change research?
Oh yeah, absolutely. I think all our universities in Western North Carolina are doing some form of climate research. Being a biologist, I'm most aware of the things that are happening in the biology departments like Appalachian State and UNC Asheville and Western Carolina and Warren Wilson and some of the other schools. I know that several schools have kind of long-term monitoring efforts of local forestry ecosystems. UNCA does have a meteorology department, so they may be doing some meteorology research as well. And as far as climate change research goes, of course, the federal building in Asheville houses one of the national climate research centers. So there's a lot of climate research happening at the federal level inside the federal building all the time.
Yeah, that's right. The federal building, there's one person I know there who was one of the Nobel Prize winners for the international group that did the climate research modeling.
And I should thank our board member, Deke Arndt, who is a climate scientist, works in that building, and provided several of the slides for this presentation. I should have done that at the very beginning, but thanks, Deke.
Well, if we don't have any more questions, I just want to thank everybody for coming. Bob, Josh, do you have any other closing statements?
Thanks for everything you're doing, everyone, to adapt to climate change and mitigate the worst effects. Let's do our best to bring all the creatures we share this planet with through it with us.
And stay tuned. Try to stay up to date on research, because science is changing continually. We're learning so much more, and we have more technology to learn about it faster these days than we used to. So it's out there, and make sure you try to listen to the right sources, rather than many of the interesting internet stories you hear, or claims you hear thrown around.
Great. Well, thank you guys all for coming. This will be up on YouTube in about 24 to 48 hours, and we're so happy that you were here, and we thank you so much for all of your time. And we hope to see you at our next MountainTrue University in June about our solar program. Bye, everybody.
Thanks, everyone.